Part 2, please make sure you get these copied down. How we can use these double angles to solve. Again, we'll be using this year and as well as next year a lot in calculus. Now this rule is I don't want sine of 2x. I want to replace my double angles. They make it really hard to solve if you're not careful. So I could replace sine of 2x with just 2 sine x cosine x. And I'm still left with this plus cosine x, and that's going to equal 0. Now, why you may like this, you may ask? Because if I look at both terms, they both have a cosine of x. I can factor that out. And that's going to give us 2 sine x plus 1 equal to 0. Using a little bit of algebra, set them both equal to 0. Here, we get the cosine of x equals 0. Here, the sine of x equals negative 1/2. And now we can just solve this. Where is cosine equal to 0? We should just know that one, right? Cosine is equal to 0 at pi over 2 and 3 pi over 2. Sine's a little bit trickier. We'll go ahead and get our reference angle. The reference angle, sine is equal to 1/2 at pi over 6. And of course, because sine is negative, we're looking at the third and fourth quadrant. So we get 7 pi over 6 and 11 pi over 6. Ta-da! Now for number 11 is a little bit tougher, we'll do this one last, okay? Just because that's going to be a really tough one. It might take a while. But let's take a look at number 12. Here, I want cosine of 2x. Now, if you remember, for cosine of 2x, we have a few choices. I can do sine squared minus cosine squared. I could do 1 minus the sine squared, 2 sine squared, or I can do 2 cosine squared minus 1. The question is, which one do I want to use? Now, if all possible, I want to avoid different variables. Okay, I want to avoid different variables. So if I have cosine, so if I'm going to replace this cosine of 2x, I'm left with this cosine. So I look over here. Which of these only has cosine? 2 cosine squared. If this were a sine, I would use 1 minus 2 sine squared. So I'm going to replace this with 2 cosine squared of x minus 1, and I got this minus cosine of x equals 0. So this becomes 2 cosine squared of x minus the cosine of x minus 1 equals 0. Don't bring the 1 over. You cannot solve it that way. Please stop trying that. Bad students. We're going to factor. This is easy. 2 cosine of x, and we get 1 and 1. Because I want negative, this becomes negative, this one's positive, equals 0. And again, just do a little bit of algebra. Cosine of x equals negative 1/2. Cosine of x equals 1. So when I now solve it, find my reference angle. Where is cosine equal to 1/2? That's our pi over 3. So my angles, cosine is negative in quadrant 2 and 3. So in quadrant 2, that's going to give us 2 pi over 3. And in quadrant 3, 4 pi over 3. And for our last one, for cosine equals 1, again, this is one we should just know. Cosine is equal to 1 at 0 radians. Like so. Very cool. All right, let's take a look at number 11 up here. Now, number 11 is going to be kind of tricky. You could solve this by using your double angles, but that's, our sum and difference. That's going to take a while. I'm going to use an algebra trick. What is sine equal, tangent equal to, but sine of x plus pi over the cosine of x plus pi. And the reason I do this is now I'm going to use a common denominator. It's cosine of x plus pi. And on top, I get the sine of x plus pi plus 2 sine of x plus pi cosine of x plus pi equal to 0. Now, the reason I do this is because if I cross multiply, that whole denominator just goes away. And if you look on top, what do both terms have in common? A sign. I can take out the sine of x plus pi. And that's going to give me 1 plus 2 cosine of x plus pi equal to 0. And now if I solve each one, I'm going to get the sine of x plus pi equal to 0. And I get the cosine of x plus pi equal to negative 1/2. Now, to speed things up, I'm going to give you these answers, but you can check them. Sine, remember, is equal to 0 at 0 and pi. So I'm going to get x plus pi equal to 0 and x plus pi equal to pi. If I subtract pi, I get negative pi. If I subtract pi, we get x equals 0. Now, where is the cosine equal to negative 1/2? Well, the cosine is equal to negative 1/2. We already did that over here in problem 12 at 2 pi over 3 and 4 pi over 3. So if I subtract pi from here, so if I minus 3 pi over 3, remember that's subtracting pi, we get x equals negative pi thirds. Over here, if we subtract 3 pi over 3, we get x equals pi over 3. Now be careful of our domain. We don't want negative 3 pi over 3. We want between 0 and 2 pi. So this one is out of our domain. We don't accept it. Now some people will say, hey, can we use 5 pi over 3? Because remember that's 5 pi, that's the same as 5 pi over 3. And that would be okay in some cases. But right now we want to make sure if we get a negative, we don't want to use it. All right. Please work on these tonight. Try these again if you need to, and make sure you come tomorrow with your notes. Thank you. Bye-bye.